Hello and welcome to this video. My name is Matthias. I'm the technical support engineer for Trimble's eCognition software, and today I would like to talk about the algorithm called pixel-based object resizing. And what this algorithm does is actually growing or shrinking based on certain criteria that you define. So it's really nice to reshape your objects. This algorithm has three main functionalities, which are growing, coating and shrinking, and this is done on a pixel level. The first one that I wanted to show you is growing. So this figure should illustrate this process. So on the left hand side you have the initial object, on the right hand side the object after growing. So it just adds one row of pixels adjacent to the initial object. You also could use coating. In this case it's very similar to growing, it's just putting the newly added pixels into another class. The last one here is shrinking, and this is more or less now self-explaining. So instead of growing, it shrinks by 1 pixel. Using shrinking you can put these new objects directly into a new class, just as using the coating for growing the objects. That's the theory more or less, and let's go into a real-world example in eCognition to show you how you can use this. So here's a project set up in eCognition. I already did a segmentation and a classification of water areas. So we have the class water, we have a class potential water. I merged them together and I have this project with a classification already. And we're going to use pixel-based object resizing to show you what impact that has on your objects. So let's zoom in into a more detailed view where we actually see, because we're working now, we're growing on a pixel level, so the change is very little. So first what we're going to do, we're going to append a new process. We're going to look for the pixel-based object resizing. By default it's set to growing. We have to define the class that we want to grow. In our case water, so we just want to grow the water class. And if we execute this one, each water object will grow by 1 pixel. And if you execute this a few times, you're going to notice that the class water is growing into all directions and also into all classes, so in unclassified as well as into this dark blue class called potential water. In the next step I'm going to show you how we could limit this growing into different directions. So you could say only grow into X plus direction or minus Y direction. So let's just change a few settings and see what happens. Let's simply change it to only positive. So this algorithm can only grow into positive X and Y directions. And if I'm going to execute it a few times, you're going to see that it's not growing downwards or to the left, because this would be minus X and minus Y direction. We also can say no, only grow into X positive direction, so in this case only going to grow to the right hand side. These settings can be valuable if you, for example, looking for shadow in a certain direction of your classes. Okay, I'm gonna copy this process. You can just copy and paste it, and in this new one I'm gonna show shrinking. So what shrinking does is more or less exactly the same, just the opposite direction. I'm just gonna say it can shrink into all directions, and what this does, I'm gonna execute it twice and then zoom in so you can see what's going on in detail. So you see we executed it twice, so we have a buffer of 2 unclassified objects around our water class. Let's change the class for new image objects to buffer. And if we execute it now, you're going to see that instead of putting these new objects into unclassified, it's going to classify it or put it into this class buffer. In the next step, we're going to limit the minimum size of the objects. You can use this when you use shrinking, or maximum object size if you use growing, for example. So let's just set minimum object size to 1000 and execute it a few times, and you'll notice that the water objects can't become smaller than 1000 pixels. I'm just gonna execute this a few times and then let's prove if my hypothesis with the minimum object size is correct, and check the size of the water objects that are left over. Now nothing happens anymore when I execute this algorithm, at least in our view. So let's check if I was lying or not. Display the area in the image object information, and every water object now should be maximum 1000 pixels in size. And that's true for all of the objects that I've tested. So let's simply duplicate this process via copy and paste, and let's look for coating instead of growing or shrinking. And if you remember correctly, when using coating, you can define the class for the new image object. So in our case, we can use buffer potential water. We're just gonna go for buffer, hit OK. Now we're gonna first delete or clean up the classification, delete the buffer so you see what's going on when we're gonna execute this. Let's merge the unclassified objects and execute the coating. Now you see a nice buffer around the water objects in yellow. So it classified the growing pixels into objects with the class buffer. And you also could use other classes like water. And the difference to growing is now that you have additional objects, it doesn't merge them together. Right. Let's clean this mess up. I'm just gonna merge the water objects. And I'm going to show you another setting in this algorithm. And this setting will limit the growing based on a class. So we're going to set the candidate object domain. We can define a class filter. We're going to set it to potential water. And now it's going to only grow into pixels that belong to an object classified as potential water. Let's increase the number of cycles so we don't have to hit execute 100 times, so just setting this to 100. And you should have noticed that the growing was limited to the class potential water. Okay, one last setting that I want to show you is that you can choose also, instead of candidate object domain, a class filter, you can use a pixel layer constraint. I'm going to use 2 layers and just say for the first layer it has to be larger than an absolute value of 1100, and for layer 4 it has to be lower than absolute value of 600. Let's have a look at a nice animation. So actually what this now does is it only grows into pixels that are adjacent to the class water and that they fulfill these pixel constraints that we defined. What you will notice is that some areas that are obviously water won't be classified as water because they're not touching water, so there's no chance that this algorithm grows into these areas. But I often use it actually exactly for this, for classifications of river systems. So if the initial segmentation didn't pick up the small river arms, often use this algorithm to grow into these arms, and I would say this is pretty satisfying to watch, and this works pretty well, I would say. Instead of using absolute values, you also could use value of current pixel, which is always relative then to the current pixel value. And you can set the tolerance mode to percentage or absolute. If you use these settings, it only will grow into the next pixel if this is fulfilled relative to the seed pixel. So we've reached the end of this video. We talked about pixel-based object resizing. I showed you how to grow, shrink and coat objects on a pixel basis, how you can set constraints and so on. That was quite a bit of input for you guys. So we decided to split this into 2 videos. We're gonna have another video looking even into more detail regarding this pixel-based object resizing algorithm. Alright, so I hope you enjoyed it, you learned something new, and if you have any requests or comments, please post them underneath the video, and have a good day.